Hi, welcome to a new tutorial. In this tutorial, we're going to learn about the foundations for steel structures. In this model we got here, which is being converted from 2D into 3D for us to visualize, and we'll see what the foundations for steel structures look like and what items of work we need in order to establish these tasks here. So let's have a closer look at what we got here, and we can see here you got these shapes are what they call the pad foundation, and these are the rebars where it form part of the foundations. Then again we come across this item here, which is called the holding down balls set, which contain numbers of balls fixed together with parts they call cones and plates, and the apply plate will connect them all together, and they are all fixed into the foundation. And the reason for that is for the steel columns here to be fixed, erected, and fixed into these balls, and will be part of the steel columns, which the whole purpose of to transfer loading from the building into these foundations, and in return these foundations will represent a resistance, a balance to these loads transferred from the structure. But the model, the project, when it's been given into the operator for on-site, it will come with a drawing like this one, which is exactly the same as the model which has been converted. What we see here, we see the pad foundation as the 3D model, and this shape there, it represents this the green holding down balls, and this H shape there is the columns themselves. So when it comes to here, we have some information. Basically, is we've got the grid lines, and which give us the position of the foundations, and they give us the position of the holding down balls, which they are. You can see them in these circles, which they are in a 3D plan view, which they are the holding down balls. The exact positions they are given, or from the drawing, from the CAD drawing, we can see, like as here, we can see these coordinates. They are the global coordinates, and we can either leave them as global coordinates, or we convert them into the local coordinates, or the التحتيات المحلية. So I mean, if we need some more coordinates, we can. I show you now. For example, we got this one here. Say we got for example this one here, and I need to get some more coordinates into, for example, this one here. Transfer it. So we got here the coordinates, and it will have the new coordinate for this bolt here. So and so on, we can get any coordinates you get from all these bolts, and you can set them out on site, whether traditional way, where you can input them with the total station, or you can do them digitally, like I will show you later on, which I use the digital way of using the coordinate system in setting out where I can use all the digital spaces, where we got the CAD itself will be imported into the machine, and for example you have all this coordinates, you can just pick on them, and basically you will set them out with the total station, the robotic machine. Hopefully in the other tutorial we will go through some more details about how to use the digital way of setting out, and how we operate it on site. But for now, let's have a look now let's know more about these holding down bolts, how they are being assembled and how we can set them out on site. So let's have some, we got some pictures here, say that these are the items of the holding down bolts, where you got the bolts themselves. They are specified by the structural engineer, and you got the other items where the plates and the cones. These are the plates to be fixed right at the bottom of the bolts, and this is the top will be where the columns will be penetrate through these ends, and these plates can be any many shapes, could be rounded, could be square, and can be fixed into the pad foundation الأساسات. How about this? These are the cones, where it's part of these items, where in the end it will give us a flexibility, like we see in this picture. These cones, once it's fixed and it's been taken out after, if there is any error in the setting out بالتوقيع المساحي, we have flexibility to move the bolts in 360 degrees to get into the exact position. So we have a play here, we have a play of 10, 15 mil or 20 mil either side of the bolt, but preferably we have to get these bolts set out within 5 mil. But for emergency and if there is any error, we can be pushed by 10 mil, 15 mil maximum. So the holding down bolts, they get assembled on site, and they have ready to be fixed and ready for concreting. Like in this picture here, you got the steel beams and the pile cap or the pad foundations, and we got this plates is being ready for concreting, it's been fixed, and if the steel is in the way of the bolt, it can be displaced either side to get this bolt through. So once these holding down bolts are assembled, you can set them in, or we can even have a better look now here. If you can go to the shape here, you can see better. You can see that in each pad, let's say this one here, in each pad foundation there is holding down bolt set, as you see in here. So they are all within the structure itself and represent part of it. So the columns are being erected, and the columns got a bottom plate where is the bolts penetrate into the plate to form the basic of the column is fixed into the pad foundation, and so that will ensure there is no movement or any sway with the column. It's all fixed into the foundation. And we have got a picture here again about the columns, how they are manufactured with holes into it, so they have to be erected, and the bolts will be exact position where they're going to go through these holes. So having been the holding down bolts have been assembled and set out, it can be checked by the engineer on site to make sure they are all in the exact position, and a survey can be arranged to ensure that these are set out in the exact position, which we call them the pre-concrete checklist. For example, in here you come across here and you survey this, and will give you the exact position. Any position here you want for the holding down bolts is being checked, and as well as to ensure that the level level of these holding down bolts is being set. So we know this is a plate which is going to be, you know, set on the concrete, and as you see, it is 20 mil above the concrete level. So this is all about the holding down bolts now, and the other part is we need to have a look at is the reinforcement. The reinforcement make a big part of the structural foundations, but not all foundations are reinforced. It's depending on the design specification. But in this example, I had to show you some reinforcement, which is typically it comes like this, where it's been fixed, and the holding down bolts, it's been fixed into this reinforcement ready. And if you look at it from the side elevation or side view, you'll see it's become like that, where you see the reinforcement and the holding down bolts fixed into the reinforcement way down, and part of it they call it projection, where the steel frame will sit and penetrate through these holes. Let's have a look now, see if we can do something like that, you know. So we know that this pad here is ready. The hold down bolts have been set and the concrete has been set, and it's ready for let's have a look before we go that. So this is ready for a column now. So once you can easy now on site, we just duplicate what happens on site. So let's erect some column here, and that's fine. This one here, this one here, and you come here, and let's say they do that on site, and that will go in to the foundation level. We are now at this level, so we go back to the 3D, and we'll see that this is going into this. We just go like that, and this is going from foundation into, let's say, take it back to second level, like, and this is gone to the second level. Yeah, and the beam can take the shape after the column is being erected. The same principle where you just extend this into the other one, and you got the beams are ready as well. So now we explained the holding down bolts, the pad foundation, the pad foundation. Now we're left with the reinforcement. Yeah, the reinforcement or the rebar is usually specified in a bending schedule. It's being supplied by the design office, but if you are working for a company which they are design and build, so you could design it yourself, or you can work within a team to establish this reinforcement. So let's have a look at an example of if you decided to establish some reinforcement into these pads within the design team. So let's say we pick any pad foundation here. For example, let's pick this one at the grid line B. So at the grid line B, we try to establish some reinforcement now, some rebar. So we got the cross section here. From the cross section, we can organize what we need for rebar this. So to start with, I will need some U-bars. So this one is This U bar is fine, but what we need is to set it to maximum spacing, which they are usually 150, and we have it the shape, and then we need some links as well. This is just to show you that how can be done if it is needed to. Let's have some links, and in this equation let's have then fixed numbers. I would say 6 though. 6, and let's have them at this shape now. So we established the reinforcement here. All we need is to make them appear and have a good look at them. That's done now, and we'll have a quick look at them. Here we are. That is established there. Just to give you an example about the reinforcement we done there. That's the one we just done now. So this is give you an example about how to reinforce some pad foundation if you wanted to, and if you are working in a site where you need to reinforce it, or you need to write some details, reinforcement details in the pad foundation to comment with the design team, or to add rebar or omit rebars as the project progress. So let's have a look at the list we prepared earlier on with the questions and answers. What we got left in this list was what surveying instrument is commonly used for setting out foundation and holding down bolt sets. We did discuss earlier on about how we set out these foundations and holding down bolts, but we do have a picture now which shows the instrument. There are many instruments available in the market, but this is one of the instruments. It's the robotic. It is being operated by one person, the engineer or the surveyor, which you got the monitor there, and you got the total station itself there. And as I explained to you earlier on, you can. This is how I operate this machine, where you got into you got to many programs you got, and either you use this one, or I'll give you an example where you can got all the data there, or this is for foundations, or sometimes or for let's see if this one is for roads. You can get some, when you're setting out roads, you can have the shape of the road, and you can have all the points to do with the road. You just you go on any point you want, and it will give you all the information of the points, and the coordinates levels, and you can set them out as you progress with the job. So you go to there, and you got stakeout, survey, you got many programs available. So this is our briefly the instrument, and hopefully other tutorials we go even a bit more details. The rotating laser as well used for the foundation, but that will be discussed in part 3 of our tutorials. What type of concrete we use for foundations, and how we calculate digitally the volume of foundation. So let's have a look at how we work out the volume of the foundations. In this program, we can there is a section there where you can go into the quantities and schedules, and from that you look through it, and if you want reinforcement or if you want foundations, basically you go through it and you pick what you want, and then you have to deal with how to, for example, structural foundations. You go to that, and then okay, and then you come to a list of things you do here, and after that is you come to across a sheet where you can give you the details of all the foundations. For example, let's have a look at this one here. It's prepared for this model. Is basically you can it's called structural foundation schedule for this one. You have sorry, let's delete that and take that off. So this one here is the foundation type. You got the area, the elevation, but what we are interested is in the volume, the number of the pads, and the volume is 14 cubic meters. And you got many other details. You can sort them out as you go there with filtering and sorting with this model. So this is how it worked. It will all come digitally from the model, and so you can send this report into your team and the client, whoever requests these details. So now we have discussed. Let's have a look back again and let's get the. So now we discussed the volume. Basically, traditional way you can. In the additional way, we can click and you can know it. You can tell the volume of this by getting into the details. For example, this is 1 meter by 900 by a meter, and then you count the number of the foundations. And if you want to do it in the traditional way. With regard to the concrete, what concrete we use here is all specified by the structural engineer, whether it's C25, C30, C35, and what I mean by C is C35 and C20 is that's the compressive strength, where it will reach in 28 days for that specific concrete. And usually in construction sites, we take samples for when we pour the concrete for these foundations and it's sent to the lab. We get the results later on to confirm that we are using concrete to the specification. So that is with the concrete specifications we use in the construction of the foundations. What we have left with here is the drawings. We see in the drawings. One more thing I need to show you for the drawings. When we come in here, that shows you the pad foundation and the holding down bolts. But they usually give you other drawings where they show you the arrangement for these bolts in this arrangement, so we know exactly what they look like, and all the offsets are being given, and what type of bolts you require, the length of them, the diameter, and so you get equipped with all these details to establish the construction of foundations for structural for steel structural buildings. Well, I hope you have benefited from this tutorial, and if you enjoyed it and you would like to see more, please subscribe and like, and I will see you again. Thank you.